13, solving the CAD-CAM problem with pattern. And I'll just turn this right over to Scott.
All right. Okay, I'm finding the beginning of this. It was a longer chapter than I expected it to be. All right, here we are, chapter 13. Let's see, I hear a little bit of an echo, and Forrest, I wonder if it's you. Can you turn off your
microphone? Yeah, sure.
Yeah, let's see if that fixes it. Okay, yes, that appears to fix it. All right, I was particularly interested in this chapter, but I'm even more interested in chapter 15, which is basically how he handles crinkles and how you can get a better approach with that. In preparation for today's session, I actually went out and bought Christian's book, and I found it to be probably one of the most profound books on just attempts to tying together concepts in such a way that they complex problems and issues can be communicated amongst a group of people with the highest probability of them being able to communicate to find the best solution. Like the authors in this book, I think they're right to follow his pattern. It's a very interesting book. I highly recommend it, even though I'm only a little over halfway done with it. Okay, so what we're doing here is the author is lifting up our traditional sense of design patterns as used by the Gang of Four. And what he's doing is he's elevating above that to attempt to help out with, you've got a complex problem that's going to use a number of patterns. How do you order the patterns in such a way that you break down the problem appropriately, and so that you get the patterns in the right order? And we're going to talk about the structures of what you have to think about in order to accomplish that ordering. So we're going to do this by walking through the methods needed to solve the earlier CAD-CAM problem and to see if we can come up with a better approach or a better design. We'll take you through the initial design phase, and we're not going to worry about the implementation, and then we will compare the new solution with the previous solution. So what he's going to attempt to do is jump to the very top of the overall view of the CAD-CAM problem and see if we can start analysis right at that level. Okay, so chapter 3, define the requirements for the CAD-CAM problem. And what he's basically got is an application that's going to interface a large engineering organization to support their CAD-CAM system. The basic requirement is to create this program that can read a CAD-CAM data set and extract the features that the existing expert system needs to have processed. The system's supposed to shield the expert from the CAD-CAM system. So the complication is that the CAD-CAM system is in the middle of changes, and potentially there could be multiple versions of CAD-CAM to interface to. So that's a primary part of the programming problem. So he got his initial requirements from interviews with the the people that need the system. And he came out with the high-level system architecture shown in 13.1. So let's go down and look at that. Basically, the overall organization has this big process that coordinates the expert system with the CAD/CAM systems, and what he's developing is the geometry extractor. So it's going to read a CAD/CAM model from the expert system, and it's going to make sense of the parts being asked to make initially using what ultimately is a subset, the sheet metal parts. And each sheet metal part has some amount of complexity. We've already gone through the different kinds of parts that it's going to make. And we're going to make everything so that it is configured to most easily play with at least 2 different CAD/CAM systems without having to change the expert system, nor change any more of the code we're developing than necessary. That's the design objective. So when he started using this technique, he doesn't always try to think in patterns. And this is, I think, where the struggle is with Christian's approach, and that is you have to jump to the high concepts and then think in terms of patterns, and getting those two to work together has certainly taken me some practice in going through this exercise. And I think what he says is pretty useful. Okay, so you're looking at something and it's really complicated and you don't have too much of an idea of how to go about it. And what he's saying is that if he can think in patterns, he has a higher likelihood of getting into the breakthrough insights that will give him the aha moments so that he can say, okay, this is a better solution than what I've been thinking about. And so he's found it useful to use this general approach that he's going to go into further after this chapter. And so he talks about how Alexander's approach started looking really attractive because he wasn't getting the solutions he wanted with the CAD/CAM problem. He knew he could, and I know we've all felt this. You've got a solution, you don't like it, something better has to exist. But how do you break out of your present pattern of thinking so that you can see that better solution? So he took the proverbial break. Most of us have done that. And if you're lucky, for me, it always happens at 4 o'clock in the morning. I wake up and that's when my aha moments happen. He walks and this time it got 30 feet. He went, oh, I've got an approach. So he says, Christian was telling him, think in terms of the patterns. Now, this was a little bit of a hard chapter for me because are we talking about Christian's patterns or are we talking about the Gang of Four patterns? And really, we're talking about both. And they're very closely related. What I was missing was, and I struggled to get this, took me several times, is think in terms of the patterns, in terms of the context for the patterns, which the Gang of Four does talk about, but it's like they presume you already kind of have that higher level view, and I didn't. So like so many people reading this book, I'm going, okay, patterns schmatterns. You know, I don't know how to do the top level analysis to get in tune with what patterns would work. And that's what I think he does a really good job in this chapter showing. So going back to the concepts in the earlier chapter, he had, and I had forgotten this, he had identified all the patterns that would have something to do with the problem domain he was in. So he says, look at the essential concepts and don't worry about the details yet. In other words, okay, you've got a set of patterns that could work here, but you don't know in what order to apply them. So here's how you look at the essential concepts and kind of get what you want. So admittedly, this only works if you can understand the entire problem domain in terms of patterns. Meaning it doesn't work all the time, but it gives you a place to start. And that was what was really useful. You have to fill in the rest by identifying relationships amongst the concepts in the problem domain. And the method for doing is using commonality and variable analysis, CVA, and I'm really interested in getting into that. So this is kind of a step that I'm hoping is going to make that easier. All right, so here it is, the process of thinking in patterns. Identify the patterns that I interpret, find the patterns in the problem domain. Well, I don't know, but maybe with a little experience, you can learn to identify the patterns that would probably be useful and start with those. So that's number one. So we have the patterns, and he's going to go through, okay, how do we order the patterns by context creation? And where I got hung up is, okay, well, what's a context? And I've gone through several evolutions of what a context is. And it keeps morphing a little bit, but what a context for me is at the moment is that it is the problem domain that you're looking at currently. It's all the forces and tensions that are creating the problems that you're trying to solve. And you're trying to identify a pattern that will at least get you started. So the key idea is that as you get started, you have the overall context, which is really complicated. See if you can find a crinkle there in which you can identify a pattern that will solve that crinkle. And then that solves the problem at that level of abstraction. Now, take a look at the new context, or perhaps the multiple derivative context, but look at them one at a time. For each context, find another pattern that could fix it, create it, solve the next crinkle, and keep doing this from the top down until your flows and your patterns are all identified. So there you have your pattern that breaks it up into more contexts, and just keep going down until everything comes together. And just keep repeating. Rinse and repeat. So, and then as you go along, you will add detail as you identify what needs to be identified. And so you expand your method and your class definitions. And pretty soon you have all your APIs worked out. That's what we're going to do. Any questions or comments thus far? I got my headphones on and I'm not hearing anything, so. All right, so the first step, identify the patterns. In the previous chapters, he identified the 4 patterns in the CAD/CAM system.
Hey, Scott, I gotta make a correction before people get confused.
Yes.
It's Christopher Alexander.
What did I say?
Christian.
Thank you. Okay. Appreciate that. Christopher Alexander. Yes, you're right. All right, so we have the abstract factory, the adapter, the bridge, and the facade. I like how he says no other patterns stand out at this time, but I'm open to additional ones showing up. What that translates to me is don't sweat it at this point. So, yes, change Christian to Christopher. Everybody put their mental grep on and make those substitutions. Okay, so what are the forces? What are the issues in the problem domain at the top level, and how do they line up with the patterns that I know? All right. So he will work through the patterns that I know are in the problem domain. At this level, I will select them based on how each pattern selects the context for the other patterns, or creates the context for the other patterns. I like how he just breaks it down into, wow, I really don't know, so let's brute force it. What are the possible relations between these 4 patterns? And you can see we have a completely crisscrossed set of every pattern could potentially create the context for any of the other patterns. So now the analysis problem is okay, well, what are the real outcomes of, which relationships are we going to select? So if you have several other patterns, it may look like the pattern could get really involved. With a little experience, you'll find out that that's probably not true. And if it feels like that, you may simply not be remembering an existing pattern that would fit very well. And in my case, I've tried to apply these concepts, and another thing I've been working on recently, I ended up saying to heck with it. I did it a different way, and then after I did it, the next day I realized, oh, that was the decorator pattern. So sometimes you don't remember the pattern, the word, but you may remember the way, and it sneaks in and helps you out anyways. Okay, so for here, it's wonderful because this is education, and there are few enough combinations that we can look at all the possibilities. So we look for what creates context. So when we say one pattern creates context for another, is one definition of context is the interrelated conditions in which something exists or occurs in an environment or setting. In the courtyard example of an introduction to design patterns, Alexander said that a porch exists in the context of a courtyard. Courtyard defines the environment or the settings for which the porch exists. A pattern in a system relates to the other patterns in the system by providing a context for these other patterns to exist. In your analysis, it's always valuable to look for whether and how a pattern relates to the other patterns, to look for the context that the pattern creates or provides for the other patterns. We may not be able to find these every time, but this increases your odds and you'll get a higher quality solution. So looking for the context is an essential tool to add to your bag of analysis of designs. Deciding on what pattern creates context for other patterns is key. So if you can remember these concepts of why they exist, abstract factory pattern creates sets of related patterns, families. Adapter pattern makes a class A usable by a class B. A bridge pattern allows for different implementations to be used by a set of related objects, and a facade pattern simplifies. So if you keep those problems and solutions in mind, these can come to mind for you. And I admit, I got a long ways to go on making those second nature. Okay, so if you can remember those meta descriptions, then you begin to see which one creates context for the other. So although I can reject the abstract factory as a topmost pattern, if he reads a sidebar, he can use its meta description to realize its context is defined by the organization of the, that sentence doesn't read very well for me. Yes, its context is down on the list of things from the top level context. So he can delay applying the top level, the abstract creator pattern till later, because he just knows it's not going to be at the top level. That leaves that cuts the number of possibilities in half. And so now we can look at these other possibilities. So a rule to use when considering context, sometimes you'll notice that your experience tells you that I'm not going to instantiate my objects until I know what my objects need to be, which is going to be a result of flow and relationships. So briefly, it turns out that neither he nor anybody else has found that worrying about any of the patterns for instantiating objects are going to be the first thing you look at the top context. Now, I find this is useful. Senior-most patterns constrain the other patterns. And that is, the senior-most is the term for the one or two patterns that you can identify that establish a context for the other patterns in my system. And I'm starting to believe that, your senior, if you work at the top, you find your senior-most, and you find a pattern that works for the senior-most context, then you've solved that level, and now you go down, and senior-most now is applied to the next level down, and you just keep doing that all the way down to your systems defined. And I applied that retrospectively to this other project I was working on that seems to work pretty well. Okay, so if you're new to patterns, then you may have to brute force it, as we're working through right now. And the two rules of thumb that he uses to try and establish these, which pattern wins in these contexts is, does one pattern define how the other pattern behaves, or do the two patterns mutually influence each other? So is there a relationship between the patterns? And so he goes through and he analyzes them. And he says, well, the adapter pattern is about modifying the interface. And he says, okay, so we have an OOG feature, so we know we're going to have to adapt to that. The bridge pattern is about separating multiple concrete examples of an abstraction from their implementation. So in this case, the abstraction is feature, the implementations are version 1, version 2. We have multiple implementations for the feature. By golly, the bridge will use the adapter. there's some relationship between bridge and adapter. Are the patterns interrelated? Meaning, can I define one of the patterns without another, or is one of the patterns needed by another? Well, let's take a look. I can talk about the pattern as separating the features from the V1 and V2 systems without actually knowing how I will use the V1 and V2. In other words, we can use the bridge to define the abstract without concerning ourselves with the concrete. Then after this is defined, the concrete implementations can be adapted, so we're already getting verbal cues about what's going to happen here. So the bridge pattern is certainly going to use the adapter, but the adapter is not going to have anything to do with modifying the V2 system interface. So without the bridge pattern, the interface doesn't exist. So the adapter pattern exists to modify the V2 system interface to the implementation the bridge pattern defines. So the bridge pattern creates the context. Here's a decision. The bridge pattern creates the context for the adapter pattern. You can eliminate the adapter from being the senior-most pattern here. So far, the bridge pattern works, or is the winner. And that's useful. It's kind of a brutal level of analysis, but it's a nice discipline. Okay, so we have a bridge facade. And because he suspects that the bridge turns out to be the primary pattern there, I do not have to consider the adapter facade relationship. So by picking the bridge facade first, he won't have to worry about the facade adapter. He's only worried about senior-most now. So here we go. It was obvious to him, and I agreed as when I looked at it, that the same logic that applies to the bridge and adapter also applies to the bridge and facade. So it's the same outcome. The bridge is the winner. So he's starting with the whole, going back to the beginning. I do not, so the bridge looks like it's going to be the winner. Can he find a way to confirm it? He doesn't have the context for the bridge yet. So now we go to 2B. We got to state the problem as a whole. And here it is. I want to build a system that translates CAD/CAM models into an NCNet so that he can send it to the manufacturing equipment. So he had expanded this design by noting he could use object-oriented design techniques to use a model class to get its information. Model would have two versions, one for each of the CAD/CAM systems. So we go down and the expert system is feeding out this information, and it's got models, and the models have to be generated for multiple systems. He's not worried about the design of the expert system, and so he just has to start from the model, identify the features, which we've already done. And now he's ready for the bridge pattern because he's got these abstract features that have multiple implementations. He's got the abstract, and then he's got the implementations that are required by the different machine systems. Now, and he's correct, he doesn't really have a bridge pattern in figure 13.7 because model is not varying except for the implementation. And it's degenerative. There's only one concrete model. So in the feature, I have different types of features that have different types of implementations. Then it does exist. So he starts implementing the bridge pattern by using feature as the abstraction in version 1 and 2 as the implementations. So to translate the problem, I start with a standard example of the bridge pattern and then substitute classes into it. So there it is. This has the this is, most directly from the book. We have the abstraction and we have the implementation. And so this falls out pretty quickly because we saw that's what happened in when we actually implemented this. We came up with the feature and the subclasses of the feature. So at this particular point, he's now checking to see, okay, does it work for the abstraction? What are the things that are going to be needed? Well, we already know we have to get X to get the X position, get Y, get length. So imp feature is going to have to be able to get that information, and it's going to have to get edge type from some of the features. So only features that need this information should call that method. So we'll solve that problem when we get to it. So thinking in pattern step 2C, we haven't done that yet. So given that we've got the right pattern ordering, that the bridge is the senior context at the moment, I'm sorry, the senior pattern at the moment, we're now going to apply patterns for the remainder of this thing. So looking at 13.9, was that before or after? I don't remember. Yeah, there it is. He starts out with the imp feature and the V1 imp and the V2 imp. The V1 and 2 systems now need to be interchangeable. And so this is now going to drive the requirement for the other patterns that he identified. So these have to have identical APIs. And so at this particular point, he's dropping a facade in to talk to the V1 modules that will be able to identify directly with the target machine. And I notice at this point that he's just simply using relationships here between the abstract implementation and the facade and the actual implementation. And I note this because I noted mentally it was a little hard for me to mentally get used to that. I'm going, well, why didn't you just, set the association? But I think what he's saying is this is adequate for me to prove that, or to show myself that I can do this, and whether I show it as an actual object-oriented relationship or not, that's an implementation detail. So I had to struggle through that a little bit, but it makes sense. Okay, so so applying the facade between the V1 modules, he now has something that will work for him. And he can now make the V1 implementations work. Now we got to do step 2, A and B again, and that is now he's going to use an abstract factory to solve the problem for the V2 system. The pattern is not needed because the model itself knows enough. So if the model itself knows enough, then you don't need to do functionality that's not needed. So the details of the design are still going to take some work, but he would continue with the design by following Alexander's mandate. And he talks about how he implements the details of the V1 and the V2. So in my PDF, I don't see 1312, but it turns out that's back up here. That's our new solution compared with our old solution. I think it's really clear that this one makes my eyes glaze over, whereas the new solution has much more useful expressiveness in it. And if you've read through this, one way to compare the satisfaction of the two solutions is to read through them. And so if you try and do it in the original solution, it just becomes exhausting. And in the same space that he got to a small part of the previous solution, he can describe elegantly the entire solution. And I don't think the author of this book talks as much about how you evaluate these things as Christopher does. And one of the things that surprised me that has slowly having an effect on my head is Christopher says that personal preference is the surest indicator of whether a solution is viable, particularly in a community. If you ask which one is correct, you'll find that people have a very hard time agreeing on that, because what is correct may be really hard to factually establish. And eventually, you have to start relying on people's intuition. And what he implies, or what I'm taking from it, is people trust each other's intuition and preferences more than they trust each other's authority. If you authoritatively say that the Earth is flat, then people don't even want to talk with you, because you can't argue truth, ironically. But you can discuss and appreciate people's preferences. If someone says, I prefer for the world to be flat, you can say, oh, why? And then you work in, well, I like flat because it simplifies my life in this way. And you go, oh, I see that. And then you can just say, okay, well, how does it work with, and you can solve these problems. But if you start from people assuming that they have the facts and the other people don't, you're kind of dead in the water organizationally. And I had never thought about it that thoroughly before. One of the reasons I really recommend this book, he's turned my head around on assumptions about how I thought the world worked, or just assumed it worked without having thought about it too thoroughly. Okay, and then he says, kind of in the clincher, this meets the most important criteria of all, and that is this software more easy to change? And of course it is. Adding version 3 will be
You're muted all of a sudden. Someone accidentally muted you.
Maybe his headphones died.
Hello? Scott? You're muted.
Now I am?
Now you're good.
Okay. How much did you lose?
You were just talking about the summary. Like,
Okay.
45 seconds.
Oh, okay. I won't bother to go back over it. I think it's if you've read it, particularly if you've read it twice, it becomes more straightforward. Okay. So the author shows how the standard way of doing designs can lock us into systems that are hard to maintain, and the reason is there hasn't been a philosophy of how you create layers of context so that you get the patterns to apply in the right order, is the way I look at it. And I really like how he says, I start with the big picture and add distinctions as I go. And he uses the word crinkle, and Christopher does also. And it also is, I start with the big picture and add one distinction, solve that one distinction with a pattern, and then go to the next level down and keep descending until your design is fleshed out, and just keep fleshing it out, By selecting the pattern that creates the biggest picture, that really solves a lot of problems, because now you have each layer you go down, you have a lot less detail to worry about. And so you can progress much more rapidly. So patterns give you the language to tell you whether you're looking at to deal with complex context. At the top level, things are complex, and understanding of patterns will give you an idea of, you can't apply all the patterns to the same level of context, but it'll help you identify the best pattern to get you started to split the problem up. And you will see the forces at the appropriate level, and as you descend, you will find out more quickly what patterns will work and what ones won't. And in the correct approach, they're more robust, maintainable, and alive. And you need to read the book just to discover what aliveness is. It's simple and it's complex at the same time. Review questions. Anything anybody wants to ask or add at this point? All right.
Yeah, we can do the questions first and then chat afterwards, because I think sometimes the questions bring out things we bring up.
Yeah. All right. What are the 3 steps of software design? Okay, identify the patterns, analyze and apply the patterns, and add the details as needed. Item 2 is a whole set of steps in itself. Define context. I continue to struggle about this. Context is the combination of the problem domain and all the patterns that can potentially fit the current context, or the current problem. Problem being the forces and stresses that are creating the problem.
Hey, Scott, what is your issue with context? I know in reading the chapter it's kind of vague, but when I think away from this chapter, but I think most things that I analyze, context makes perfect sense. So I don't know if your led slightly astray by the way he presents, or maybe he didn't describe it in the way that digests. I mean, I think, how do I say this?
The problem I had was that he did not really attempt to define context very much in the beginning of the book. I know because I did a search on it.
Yeah.
And so my worry is what does he mean by context? Context is a very, very vague word without context.
Yeah. No, but because I think what he means really is in the general sense of like nothing comes in a vacuum. Certain things exist. Well, I'll take that back. Some things come in a vacuum. But you know, when you're analyzing things, people do things a certain way because of what's around them. You know, and so what in the case of patterns, like he's saying, if and I'm starting to go into the thing that I was going to say at the end. When you say like the next one, the senior most pattern, in essence, he's saying, what is the pattern that is the context, the starting context, right? So in this case of the CAD/CAM problem, CAD/CAM's biggest thing is really it is a bridge. The problem is I have multiple CAD/CAM systems and one manufacturing thing, but I have one kind of features that are universal. So the features are the abstraction, but I have multiple implementations of them. So in essence, the core problem solved here is the bridge. I got universal set of features, multiple CAD/CAMs, and one machine. So I have, you know, I got abstractions that will vary with implementations. This is the highest level. And then when I zoom down, I'll see other patterns as appropriate. So when he's talking about, in this case, that's the parent pattern to jump into the next one below. And each parent has the context of children.
Yeah.
Right? I'll go sort of to the side about like, because it's hopefully it's a clear example that's not programming, but it's fresh to my mind. Like for example, and sorry to get really esoteric here. Like if you follow mixed martial arts now, ground fighting is very important. But you go, hey, why don't Filipinos go to the ground? Because in the Philippines, they all have knives. You go to the ground, you get killed. So they don't go. The context in the Philippines is, why don't we go to the ground when we fight? Because everyone has a knife because they're farmers. Right. But in the context of Brazil, where Brazilian Jiu-Jitsu comes from, it's a macho culture. So mano a mano, no interference fights are not only allowed, they're commonplace. In a place where it's safe to go to the ground, you go to the ground. In a place where everyone's a farmer and have a giant freaking knife, no one goes to the ground. Right. And then when people forget this, oh, Filipino martial arts, they suck. Well, no, they evolved in the context where everyone's a farmer with a giant knife. So if you wrestle with a guy with a big knife, you get stabbed in the belly. So there's a context which explains why we're doing things a certain way. Right. And ultimately, and then if I'm going to diverge a little bit, like the problem I have with a lot of internet chatter is people always fail to see the context of the other people. Hey, there's this guy, and he lives in Italy, and he's Roman Catholic since he was born. Well, he should understand my super liberal Western, I was born in Berkeley mentality. So it's like, no, he shouldn't, because that's not his context, right?
Yeah, I think what's useful for me is this book. You know, I realized I didn't really understand what he meant by context. And
Scott, you're muted right now.
Oh, sorry. You got to unmute. I'll mute. You mute. You talk.
Still muted. Scott, there you go.
It was just useful to, you know, have to wrestle with context and say, okay, you know, what's the scope? What are the boundaries of context? What does it really mean? And it's not as simple a concept as I was too vague for me before, and it was nice to kind of wrestle it to the ground. So I'm comfortable with it now, but I wasn't when I started the book. And going through these exercises revealed to me that I wasn't comfortable with it. And getting Christopher's book and reading that has helped a lot. Do you have anything more you want to add to this, Forrest?
No, I don't know. Anyone else have questions on context?
I think it does give on page 151, it does give like a definition, like one possible definition. It says one definition of context is the interrelated condition in which something exists or occurs, an environment, a setting.
Yeah. And I think that's the generic definition of context in general.
That's right. The settings of this something exists.
Okay, cool.
The environment.
I think I sort of defined 3, but we can look at your little sticky note.
Okay. Going on. My interpretation is the senior-most pattern is the pattern that solves the first crinkle in the current context. So it sets up the descendant context so that another pattern can solve that crinkle. And I like to express it at this point, it's turtles all the way down. Okay. Forrest, I'm hearing an echo again.
Okay, I'll mute.
Thank you. So in comparing 2 patterns, what are the 2 rules for discerning which pattern is senior-most? Does one pattern define how the other pattern behaves, and do they mutually influence each other? Generic structure of a pattern, that's, come up with a standard diagram and annotate it. And when is it used? It's used to provide a precise summary of whether a pattern addresses a context. So you can have patterns by having these patterns in mind at the generic structure level, you can mentally select the one select those that might be useful. Okay, now we get to the preferences questions. Can a pattern always be defined in terms of, can a problem always be defined in patterns? If not, what else is needed? Mine is kind of an evasive, not always. In the case where it's not, maybe be able to be defined in terms of patterns, perhaps the context is not well enough defined, or there is an unrealized pattern that needs to be created, or the user just isn't remembering the pattern that would fit best. I would probably fall in the last one. I end up reinventing the pattern.
So I think with this one, like he starts out saying, hey, I identified the patterns. You identified the patterns by implementing it. Like, this is like round 5, And so somewhere through that, he identified patterns. You don't always know what the patterns are. People with more experience may know what the patterns are. And it's all a relative thing too. Maybe it's just general pattern knowledge. Maybe I've solved that kind of problem before. And then the other thing I want to say is sometimes there is no pattern for what you're doing. So those, but I'm saying he comes into this chapter because he's got multiple chapters where he evolved a solution that got progressively less clunky. And so at this point he comes, I know the patterns. And then in this one, he quote unquote knew that he needed abstract factoring. He said, well, I guess I don't need it anymore because he got a better solution. So you don't always know. And I think that's the mistake that some people do where they rubber stamp patterns, which I think is a necessary level of learning. Learn what they are, rubber stamp them until you figure out where they don't work. And then go, oh, you know what? Don't use it there. In fact, your knowledge is is fared better by when not to use them than when to use them. But you only know that after you burn yourself a couple times. So.
Yep. As a matter of fact, I found that, yeah, if sometimes you can see a solution, you go, oh, and you do it, and it works, and you go, God, that's got to be a pattern, and then you go look it up, and there it is. All right. This is kind of a design preference that becomes accepted practice, and that is, personally for me, I think if you worry about your abstract factory first, you're going to get lost. It doesn't solve the top level problem because it's premature.
I think it's premature because it's detailed. Which factory do I use?
Exactly.
Right. So, well, you don't know. You want to know in general what to do. It was one of his earlier things about his advice was start at the conceptual big picture. Start at the big picture. Abstract factory of is it implementation A or B? That's way too detailed to be the top level.
Mm-hmm. Yep.
It's it requires knowing what classes will be defined, because like it depends on the classes that will be defined. It can be the topmost level. It's like the classes that will be defined determine the context of the abstract factory.
Yep. Okay, on interpretation 3, you know, at the end it becomes pretty obvious that bridge is the one that's going to win, primarily because of the problems with, well, the bridge is defining flow on the upper level, and the adapter is applying low at a relatively detailed level. Okay, after all the patterns have been applied, there are still likely to be more details. Alexander's general rules, designed by starting with the context, still apply. Does this ever stop? This is a very general question, so I come up with a personally. I have the notion of attempting to throw a rope across the canyon. Another way of talking about is a minimal viable product. And so I think there's no conflict with Christopher's approach by descending context levels with patterns. It's just you do this much more vertically and partially if you're doing a minimal viable product, or you're trying to throw a rope across the canyon, get established that the whole thing is going to work. Or there's some big block at the basic level that you're going to have to deal with before you can go any further.
I think it's like what you're saying, like it's good enough solution, right? At some point, like you can like go and create classes for everything, but like, do you really need it? So yeah, I don't know. Like I don't think there's a hard rule to stop. But there are rules.
No, I can hear you, Scott, because you're muted.
The hard rule for me is when there's no ROI in what you're doing, right? So like once you get like any extra effort gives you less and less return, or like zero return on your time, you got to stop. Yeah. Then it's kind of like just an exercise, or you're not really doing anything productive.
I think you go till you understand what needs to be done. And that's your RO point, which for some people need to go deeper than other people. Some guys might draw something and napkin, oh, I got it. Other people may have to go like 3 levels below. Oh, I get it. This is what I need to do. Right. So that's it. When we talk about the ROI line, depends on the person. Some guys between experience and I think general savvy may need less guidance once they go. Like in this case, once they figure the topmost pattern, oh god, if this is a bridge, I'll work the rest out. And other people need, well, I need facade adapter, blah blah blah. For other people, yeah, it depends. Your mileage may vary, but go as far as you need to understand where you need to go, where drawing pictures is no longer more effective than writing the code.
Oh. So you think this question asked about
yeah, we're still talking though.
Like a rapid prototyping and like a
well, but where
object analysis or like actually doing the coding? I thought it was more about applying the patterns and doing the coding. And you know, you can apply more and more patterns and more and more patterns, more and more patterns, but once you get something working and stuff.
All right.
I don't know. I see, you know, you can interpret both ways.
Yeah. So the last question is compare the first solution to the CAD-CAM problem. What do you like about it versus the other one? I don't know. I don't see a sticky note for Scott. I don't know if the red letters is his preferred answer on that one. Maybe better cohesion for reuse. I'll go with what I like. There are less boxes, and there's a more clear direction. So the nice one kind of like grew bigger to the right, and the first one was something in the top and then a gazillion boxes at the bottom. So as far as less parts and more clear structure. But I will say the drawback to this day, every time I see the bridge, I have to reread it to remember what it means. Because unlike every other pattern, which makes sense just from the title of the bridge, I have to rethink. What is this for again? It is because when your abstractions don't change, but your implementations do, and there's multiple implementations. And again, that's just a jumble of words. But if you, in this case, if you pull the CAD-CAM, look, slot, circle, whatever, you know, multi-punch or whatever the hell it is. These don't change. That's universal, but I have two CAD-CAM systems, maybe three, soon to be three. And so you bridge from the abstraction across and go, okay, got it. But I always have to, of the original 24 pattern, it's the only one I can't remember just by looking at the title. Right? It's like, oh yeah, got what that is. Facade, decorator, understand. You know, flyweight. That one's a little more complicated, but you know, it's like little things. So that one's like, what? I don't know. But anyway, so the problem with the pattern is someone has to understand what the bridge is. If they know what the bridge is, the box with the smaller boxes still doesn't make sense to them. And a lot of times that comes to bite you in J2EE. If you don't know the pattern, you're completely lost. Like it's 600 boxes of stuff. All right. So that's it, I think, for the text. Any discussion questions? This is kind of cerebral. This is the place where I would ask Andrew, but he's on vacation in Peru. I don't know, maybe Alex or Brett. This is something that's kind of cerebral. I don't know if it makes sense the first time you read it.
I think it kind of does, but like, definitely will have to reread it and try to go through those steps, like forcing myself to go through those steps. Because like, I definitely don't do it.
Yeah. Well, it's yeah, okay. Alex, Brett, Don, Sam, anything? Comments, questions? Are you guys even there?
Good job. No comment.
Okay. Learning stuff. Somewhere he said a little line where he goes, hey, patterns give you the language, and I go, that's the most important thing about patterns is to say in a couple of words something that is clearly, you can see here, sometimes chapters worth of material. Mm-hmm. Say, Scott, we need an adapter, and then you can reuse it. Oh, great. With one word, I told him, oh, he's got to wrap the class and change the interface to match what the other guys want. Right? So the strength there. And so here he's actually trying to go beyond that. How do we look at things in terms of pattern? And it's a very artful thing. I don't think there's no science here. It's art, it's practice, it's do, maybe you don't. Back to the ROI thing. What one person needs to understand the gist of what's going on to move forward the code is different for different people. And Scott's going to bring his book.
Yes.
I
buy this.
Yeah. I think that like some there are some patterns that are easier to spot that you're gonna need them, right?
Yep.
Facade, adapter, decorator, observe. Even like I'm looking at some of the other chapters coming out. Observer, template. There are a bunch of them. Easy to remember, easy to spot. But abstract factory and bridge, very unlikely you're gonna spot it unless you've done a bunch of times. You're not gonna see that. They're not gonna jump at you.
Yeah.
And I think that's part of what makes it hard. Like you need to force yourself. First of all, you need to do them. I think like implement them like 10, 20 times.
Yeah.
Each one, just so that you kind of have it under your belt, right? And then it's still not gonna jump at you like very, very easily. And I don't think I've implemented the bridge pattern 10 times in the last 10 years. So, yeah. Which makes me think there definitely must have been some cases where it would help.
Probably. Well, so a bunch of patterns like I came up with before the pattern, like composite. Composite's something I've built many times before everyone ever named it. So that's something I understand and see really well because I came up with it on my own because, again, the forces of the problem brought me to this solution. Observer. Observer is another one. I've done that a million times before I ever knew there was a name for it. Before there was ever a name published for it. It's like, okay, I know that one inside out because I felt the pain that caused me to make one. And some of these other ones, if you didn't feel the pain that caused you to make it, you just don't get it that much. So some are kind of obvious. And some of it's good just to see, hey, an adapter. Oh, I think people have written bad adapters before because they needed this feature here, that over there, and it didn't come their way, and they did some crappy code. So, wrap it in an object, have that object have the interface you want. It turns around and does the spaghetti they call the sub guy. We'll go, oh, well, that's a better way than I did it, which is just like wrap 3 functions around 3 other things, and you can look back. But sometimes it's good to know just such a thing exists. Oh crap, this is so complicated. What do I do? Well, you can make a facade because there's only 4 of them. Oh, yeah. So for some, the light bulb goes off, and again, I keep saying the bridge. I have to reread the bridge every time. I have gone through design patterns books tons of time as to the bridge. What's the bridge again?
They should call it switch art.
So, and then the description of your abstractions very independent of your implementations. It's totally accurate, but still, it's gibberish the first time I hear it again before I think and think and think. All right, I think we're good. Who's doing the next one? So next part is chapter, what number is it, 13?
Yes.
14. This is 13. Blah, blah, blah. Part 5, oh, it's 14. This is 13, principles and strategies of design patterns. Open, close. Oh, this is kind of conceptual. How long is it? Abstract classes versus interfaces, principle of healthy. Relatively short. We can probably bang that out in one. Who wants to do the next one? Or shall we volunteer somebody?
I'm looking at the other chapter after the common analysis.
I think Scott talked about being interested in that one.
I would love to do common analysis.
All right.
Common analysis? Well, they're like these 2 chapters are pretty short.
I don't know if they come together. Are they? Blah, 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 blah. I don't know. Did you look? Oh, you're right. Common analysis is relatively short. 14.
14 is medium.
If this discussion could take, I don't know. I think it is possible we could do 14 and 15 together. But should we not bank and just do one? And then if it's short, it's short.
If nobody volunteers, I'll take 14.
What's that?
Diego, I'll take it if no one else does.
Why don't you take it and I'll take 15?
All right.
All right.
Okay.
All right,
Sounds
then
good.
we'll
I'll be ready for next time.
hear the
In case
dulcet tones
we're
of
short.
Diego in 2 weeks.
All right.
Alrighty.
I think he's gonna go
Thank you.
You better be dulcet. I just said
Thanks.
All right, thank you.
Bye.